All right, I'll quickly just mention here that I linked in the Etherpad a spreadsheet that the core team has already seen. But for folks that are interested in Crimson, this is our first attempt. Brett had kind of requested this at looking at trying to simulate what we might see with multi-reactor by just using multiple OSDs. Previously, we couldn't do this. It didn't work, but thanks to Radek noticing a couple problems with it and fixing it, we now can do this. So these tests are basically just looking at what happens when you stick multiple OSDs on a given device with both our traditional classic object store implementations, and then also in Crimson with ScienceStore and Alien using MemStore or BlueStore. There's kind of a couple of interesting things, probably the biggest of which is that we do see good scaling with random reads and still see lower CPU usage in terms of like cycles per op. That's really good. I think that means that when we do multi-reactor, we're going to see that too. I don't see any reason why we wouldn't if we can do it with multiple OSDs. So, we'll see, but that's good news. What I am a little more concerned about is why we're not seeing better scaling with random writes. BlueStore traditionally has actually been really good compared to everything else we've got when you have like high IODEF with random writes. So we probably have some work to do there. Just even baseline with one OSD, we don't do great with either MemStore or ScienceStore. But yeah, I would have expected to see this almost kind of like a linear increase. So I have to figure that out. And then this weird behavior with sequential writes in Alien, or sorry, in Crimson. I don't know if we're just like doing some write combining through the classic OSD. We see it in both MemStore and BlueStore where we're quite a bit faster than anything through Crimson. So another thing to look at. That's it though, really. A lot of data, but those were kind of the trends I saw. Any questions on any of that? All right, let's move on then. Sage or Nihao or Josh, do you want to talk about billions of tiny objects in the Ceph?
Yeah. Um, sorry. Only. Okay. So this came up from a discussion with Software Heritage. Luik actually, I think, brought this up at a CDM call maybe like 4 months ago, 6 months ago, or something like that. They basically came back and they designed this whole architecture that sits on top of Rados to store bajillions of tiny objects. Basically, they're write once objects, they're source files. They need to be identified by the hash of the content so they can dedupe them. And they're going to write trillions of them, and they're never going to be deleted. So it's kind of a different use case than what Rados is normally used to. And their approach in a nutshell is basically to have they have Rados on the back end, and all Rados is going to be doing is storing RBD images that are like 100 megs or something like that. I can't remember how big. No, not 100 meg, 100 gigs. I don't know. They're big RBD images. And those RBD images are not actually file systems or anything. It's just essentially like a big file that's a concatenation of a bajillion of these objects. And so they have these write servers that they set up in front that sort of serialize the writes and just append to these big objects, and they dump it into Rados. And then they have a whole bunch of databases that track how to look them up later. So the main challenge that they have is that they want to be able to read an object by the hash of the object content, and so they have some other external database that you look up the hash of the object, it tells you which chunk it's in, or which RBD image, they call it shards, so which shard it's in, and what offset in that shard, and so they can go find that object. And they have to sustain certain read rates and write rates. But that's sort of the architecture in a nutshell. The main sort of sticking point is that they want to be able to look up by object ID, but then they also want this like efficient packing. And so their architecture, I think that they define in the wiki, I think it'll work fine. It's just like a whole lot of moving parts. Um, and it occurs to me that we can do almost the same thing with almost exactly the same thing, but with the sort of the tiering v2 stuff that we started to build up, using a sort of a subset of the Rados manifest stuff, Rados object manifest, that basically where you have a Rados object, where in the O node there's a thing that says actually the content is over here in this other object. So using a subset of that, we could accomplish the same thing. So basically, the idea has two main parts. You could make a Rados class. So it'd be a little bit different in that in their proposal, they have these big RBD images that are striped across Rados objects. In this proposal, we'd simplify that so that they're just Rados objects. Each shard would be a Rados object, and we'd make them as big as we think is sane. I don't know if that's 64 megs. I think we have a hard-coded limit of 128 megs. Probably don't want to get bigger than that. I think 64 megs is probably big enough. And so you'd pack many thousands of these inside a big Rados object. And so you'd have a Rados class where you say append this thing to the shard, and either would say the shard is full, or it would say sure, and the right return would include the offset that it wrote to. And then you would take that offset, and then you would create a second object in a different pool that's named after the object hash, and you would set the manifest for that object to point to the shard and the offset where the data is. And so as a result, if you want to read the object, you just read the hash from the index tier, and Rados would do its little like read thing where it proxies the read over to the chunk and it would read it out. And so like the reading is sort of trivial. Existence checks are trivial, like Rados just handles that. And then if you want to do the bulk stuff, you would go to the archive tier and you would just enumerate the chunks, the shards, whatever you want to call them, and you'd read them in their entirety. So you'd read like these big 64 meg objects, and you could stream them out or whatever, which I'm hoping would be that size. If that size is sort of big enough to get further like bulk requirements, I think that would work too. That it sort of chooses slightly different. Yeah, go ahead.
Why did they choose such huge RBD image sizes? And I assume RBD was just for like convenience sake, right? That's the only reason they were using it.
Yeah, they just need like a big thing that they can squish objects together. I don't know exactly why they chose that particular value. Their requirements say 1 million. They want to enumerate 1 million objects at a time, and so they probably just said, "Oh, we can fit about 1 million objects into whatever it is, 100 gigs RBD images." But I don't know I don't know that it really matters how big that is. But that's something to clarify with them to make sure. My guess is that 64 meg shards is a big enough bulk container that you could still efficiently like stream these out in bulk and mass. You could if you lose you could throw away the index tier and you could just read all these shards and they contain all the objects with when you put the object in there, the file or whatever, you'd put a little header in front that says like this is the hash of the object, this is the length. And then you'd stick it in there, and then you have another header, and then like you just pack these together inside this big thing. So you could just stream it in, and you could rebuild the index if you wanted to.
And it's all write only, right? I mean, once this thing is
it's write only, delete never, read frequently, probably, whatever it is.
Yeah.
So I think there are like a few implementation quirks. Because like writes wouldn't be atomic, so if you have two people trying to write an identical object with the same hash at the same time, they might append it to the same shard or two different shards before they realize that the first one already completed and created the index object. So if you had simultaneous writers, they might waste a tiny bit of space. I don't think that matters. It probably never actually happens in practice, so I wouldn't worry about it. But otherwise, I think it would work fine. The real question is for us whether we want to support that Rados manifest op. Because so far it's like a small piece of all that work around the deduplication tiering v2 stuff, and there are definitely bugs in there. I think mostly around the reference counting because I think they don't need the parts that are buggy. Like we could narrow so it's just this idea of having just a manifest that points something and ignore all the other stuff. We can even separate it into a Rados op. a separate RAID op so that it's like distinctly disjoint. But I don't remember exactly what tests are failing, so I'm hoping Mia
There are
has
also
more.
those general like tearing bugs, I
Yeah.
think, that we have to solve to get that working.
So there are, yeah, I think from my perspective, there are two kinds of bugs. There are one Turing bugs, and then so there is development going in this manifest area, which do expose bugs. They have also been fixed. So I am not 100% sure because I haven't looked like looked at all the changes that have gone in this area about how stable that is. If we can get confidence, maybe even maybe I'll talk to Sam as well because he's been reviewing some of those PRs. What he thinks about this.
Yeah. Okay. Yeah, I think that's basically I think that's the question. Like, are we willing to support this? Support this sort of narrow use case? And I guess that's the first question. The second question for them is like whether this like alternate set of like size trade-offs or whatever is sufficient for them. Because if so, I think it's like it would be way less work. Because I don't know if you pull up that page in their wiki, they've got like Postgres databases and these like a couple different servers and dispatchers. I don't know, it's like all this stuff on top. And I mean,
Yeah.
logically, it's like not super complicated, but it's just like a lot of moving parts. And I'm guessing if we can find something that is simpler, then that would be.
Yeah, I mean, they still need some of those to track the chunks themselves because they still need like their index on top of that. But I guess it eliminates at least one layer.
Yeah. Yeah, there's a whole nother layer separate from all this that's like the bigger index, but at least for the storage component then. But. So Neha, you're basically saying we should double check with Sam.
Yeah, I'll take a look at any existing bugs that are popping up currently, and also check with Sam as to how stable he thinks it is. Some of them have been like mostly test issues that have gotten fixed over time. Some are race things that have also come up. But as far as I know, recently I haven't seen any of those. So I'd double check with Sam. And in general, I like the idea, given that we are already actively developing in the end, if they can just reuse the same logic, that makes sense to me, if that works for them as well.
I think that the one thing that I might suggest that we do is that I think a lot of the complexity with the current manifest stuff is that it sort of is coupled with the reference counting, so that if you have an object with a manifest that points somewhere else, it like increments the reference count, and if you delete this, it decrements the reference count. And for this use case, we don't need that. And so I think we should make sure that it's possible to describe a manifest that like, I don't know if there's a flag or if it's a different type of reference that like isn't a reference counted reference, but it's just a pointer. And possibly like separate it out into a separate Rados op to set these so that, because right now the Rados op that you use to create this is called like set chunk. And it's like you can set basically an arbitrary manifest with like arbitrary content. And so it's like kind of like a wide surface. So if we have like a very narrow op that we know that has an actual user, then we'd be free to still fiddle with all the other stuff, and wouldn't be stuck in some awkward support compatibility weirdness thing.
Essentially, their higher level database would be taking care of the reference counting for them, so that's why they would need the.
Well, they never delete, so they don't care about reference.
Right.
That's actually.
Right. That's right.
More. Yeah. Yeah.
And that actually may be relevant for other users too, like the right kind of archival write once read many case, where they literally never want to delete for the similar kinds of reasons, not necessarily to archive it forever, but for like legal requirements or something to keep data around.
Yeah, and my recollection here is vague because it's been a while since I looked at this, but I thought that we actually had in these manifests there was like a flag to indicate whether or not it was a there is a flag for whether we have a reference. So the manifest structure, when it points to it, there's a flag on that reference that says whether we're responsible for decrementing a reference on the remote object or not. So we just wouldn't set that flag. I think all the plumbing is there. I think we might just want to make like a sort of a more narrowly scoped rate of SOP.
Mhm.
Perhaps that does just this, so that we can avoid
You
any
just use the
future
part that
pain.
works. Not worry about the part
Yeah.
that maybe like
Yeah, and then we'd be free to change the implementation if we decide later we don't want to have rate of SOPs that have references or something. Then we don't have some rich API that people are using that we have to break, or we might want to modify or whatever. The other simplifying case in this particular case is that like a reference is only ever one extent, whereas like we actually support, a whole list of a single object, logical object might have lots of references to lots of other bits, or the dedupe case, where you like chunk it up, and we don't need that here.
Sage, do you know how hard this first byte of any object never takes longer than 100 milliseconds is?
From a performance standpoint,
Yeah, I was just curious. I mean, that's an interesting
it's
requirement.
yeah.
Like,
they just want to make sure the reads are fast, I think. So
yeah, I mean, like,
sorry, go ahead.
I was gonna say, that's not likely to say never, right?
Yeah, I mean, none of these require. I mean, that there's always going to be like some 99.9 percentile where that doesn't happen. But I think in general, like if your index tier is on SSDs, and then the other tier is on whatever, like in general, the reads will be pretty quick. Because you'll hit the index tier and it'll proxy the read off to the thing, and then usually rate of stops are not more than 100 milliseconds. But it all depends on like how you provision your storage, right? So it totally depends.
Yeah. I'm even thinking about things like node cache misses if you have like lots of objects.
Yeah.
Like if you're talking about putting into like a 64 meg object, how many objects do you end up with when you're talking about like, billions of these little like chunks?
I think the other thing that we might want to that's worth considering here is that at scale, this index pool is basically 100% of your storage is ONode metadata. There's like no actual data. And so that means that your SSD is basically just RocksDB, right?
Yeah.
And then things like probably every read will be an ONode cache miss, basically.
And
so on.
yeah.
So the performance balance stuff is like a little bit different. So I think those would certainly want to be like pure SSD. Like you'd want to have like just NVMe backed in that case, so that you get reasonable performance. But I'm not sure if we've like really done much performance testing for how BlueStar behaves in that kind of scenario.
It will be bad. That is my hypothesis.
Yeah. I think it kind of depends on what. Yeah, it depends on what our expectations are.
Yeah, I mean, go ahead, Josh.
Would it be bad if it was all spread out across the entire cluster? Like you had OSDs that have a mix of NVMe and HDD.
Yeah, that might make it better. You have a little bit of metadata on across all the clusters or across all the pools or whatever.
Often the bottleneck with RocksDB is more CPU than disk.
Yeah. Yeah, and if all the OSDs are hybrid with disk and SSD,
right.
The metadata would live mostly on the disk. Yeah, that might be another. So, I think these are probably performance questions that like they could experiment with today, right?
Mm-hmm.
Like even if they're not using the manifest API, they could just like create an object with an attribute that has. They don't even have to create an object. They could just create empty objects, and like modulo 50 bytes. It's going to be basically the same as what their the end result will be, and just see what happens when they create like that number of objects, either on like dedicated OSDs or on OSDs that have some like the expected ratio of.
Yeah, so with the reference kind of design with the manifest objects, do you need to have an O node per tiny object?
Yeah, that's the idea.
Okay.
The tiny object is
Mm.
yeah. And that's
Yeah.
I mean I think the whole point of going down this path is to like get that right, so that you can just say I have the object ID, I'm just going straight to Rados, and it handles the indexing of like figuring out where that content is.
Right. Just thinking
If you don't,
our nodes are pretty expensive these days, so that might be that's gonna be a lot of overhead.
do we know how big are nodes? I'm guessing like 300 bytes, maybe 200 bytes, somewhere in there.
I think it was larger than that.
Yeah, I think so too, Josh.
Even
I
for an
don't
empty
remember what it was.
object, like an empty object, because remember there's no data bytes, so there's no allocation.
That's true. I'm not sure about the objects.
No
That might be
checksum.
a lot better.
Yeah.
Because I think for RGW it's pretty large, like in the order of 10K. But that's probably because of all the checksumming and the blob information for a large object. RBU is much smaller. I guess for an empty object.
RGW also sets big attributes, maybe. Like the RGW allocation metadata should be small because the blobs will be big because of all the hints about sequentialness. But anyway.
Yeah. I guess that's something else to measure though.
Yeah. Like they could just do a test that just like does it create without writing any data on like a million objects and just measure the overhead.
Yeah.
And they could try like filling up an OSD with empty objects and just see how things behave. That'll get them. Basically doing a stat on an object would be sort of give them some sense of how the read will behave. At least the metadata overhead of the reads.
Yeah, and that means deletes is actually a benefit because those are really expensive with VoxDB, so that probably improves their performance quite a bit.
Yeah. I mean, the other thing is they could accomplish basically the same thing by also creating these. So this is sort of the extreme version. There's like, if you take one step back, instead of using the manifest thing, you could just create the object with an attribute with that same data. And then the readers could stat that object to get the offset in the chunk and then go read it directly without having like Rados do it transparently, magically for you. And that would work almost the same way.
Right, so
and
they could
also
do the tiering on the client side instead.
Yeah, and you could take one step back from that, and instead of using Rados for this index, could just put that index in whatever, Postgres or something else, and then have their own server, kind of like they did before. And which means basically that we're using Rados objects for the right side of it with the Rados class, but they're still using the read side index.
Yeah, so at that point it's basically just Rados objects instead of RBD. And
yeah, right. Yeah. But I mean, just like looking at their diagram, there's a lot of complexity, it feels like, for if they're okay with the like size trade-off of a big Rados object of like 64 megs instead of an RBD image of however many gigs you get, then yeah.
I think it also depends a bit on like what their kind of time frame is. In fact, Postgres is a system that's already kind of tuned for very tiny data like this, and designed for working well with these kind of mappings. Or it's something that's relatively unusual for Rados. So it might be a fair bit more tuning and experimentation involved to make sure that performs well.
Yeah. On the other hand, it's well, unrelated to them, I guess, but this is work that if we are going to go down this like tiering, dedupe, whatever route, like we need to do, like we want the OSD to behave in this scenario.
Yeah, we need to fix the bugs if we want that to work anyway.
Yeah. And they could take a tiered approach, right? They could use Rados object shards and use an external database for the lookup, and then later when the Rados issues are sorted out, they could just push that into Rados and like
Yeah.
get rid of their indexing if they wanted to. Anyway.
Yeah, looking at the tracker, there's like 27 open bugs in the queuing category. I'm not sure how many of those are dupes or, but there are a number of them that are this year.
Yeah. All right, I apologize. I gotta drop off for a conflicting meeting.
Okay.
Run away.
Nice.
Yeah.
Yeah. Yeah, so talking of those bugs, some of them could definitely be related to old versions. Like I see some from 2017, etc., which we are not seeing today. I don't remember having removed any Turing tests yet. So, so I'd be curious to see the new ones, the 2021 and 2020 ones, which are still relevant. So yeah, if we really want to go down this path, then we want to see how relevant these are. And as I said, I also want to understand Sam's confidence, because some of these bugs have been ignored in the past because nobody was using it. So we didn't care too much about the priority of these bugs. But if somebody wants to use it, then we will take it seriously.
Yeah, there are definitely things around like ordering and recovery and BG logs between tiers that have not been fixed. But yeah, I'm curious to hear what Sam's thoughts are too. I pinged him, but I don't think he's awake yet.
Ronan linked in the chat window another about a deep scrub stat mismatch.
I just asked Sam to join it. He might just pop in.
He says it's not stable at all.
I didn't want to say that. I wanted to hear it from him.
I think the needing an OMAP for every small object aspect of this is kind of...
it's a little spreading.
Yeah. Maybe if we could somehow really, really scale what that means down.
Yeah, I mean, Gabi and I were talking a while back about an idea like this, where you could have a specialized pool just for storing metadata like this, or you could have a dedicated kind of type of onode structure that you wouldn't need to take much space. It would be kind of like more like maybe a larger structure that would contain these kinds of references. I guess we were talking about it as like a kind of hash pool that would be specifically designed for storing this kind of information instead of using the generic onode structures. And that could be much more efficient.
I'm still really curious with our current onode structures how much of it we actually use every time we read an onode. Like, do we actually use
That's a great question.
Yeah. Or are we really just grabbing them mostly for a couple fields?
Yeah. I mean, certainly the allocation metadata is important there.
Yeah, I was just saying, Sam has just joined. Sam, we're just curious to know your confidence in the Turing code and just the manifest op handling the OSD.
It's extremely far from being ready.
I wish you were here a few minutes ago.
Like every time a new test case gets added, it turns out a significant portion of it doesn't work. Like No, it's extremely, extremely far. It would need, I don't know, a person year of work to get to a point where it's even testable.
Yeah, I guess Sage was kind of hoping that restricting it down to a very small subset of what the manifest is capable of for this use case, namely just tracking, um, um, just purely packing many small objects together, not doing any of the reference counting stuff, would reduce the surface area of bugs. But I guess there'd still be the general tiering bugs that would affect
I mean,
that.
you still have to like write that code. So
Yes.
wait,
Look
hang
at
on. Packing many small objects together, is that
yeah,
even an advantage? Because the cache pool it's coming from still needs to store the metadata pointing at those packed objects, right?
correct. That's what we were just discussing too. That's Mark's main concern with this kind of design. Just of the metadata overhead of the individual nodes and for every object.
Yeah, my first instinct is that packing them in another pool is exactly the opposite of what you want to do. You'd want to store them efficiently as small objects in the first place in the cache pool, or whatever. A redirect makes the problem harder, not easier.
And so perhaps like a pool optimized for small objects could do this kind of thing, but that would be an entirely new, different thing.
Yeah, but that's essentially what you're signing up for when you, like, yeah, like I said, just doing the redirects part is already really expensive. It's worth it for the sort of deduplication strat, because the idea is to cut down on total space used. It's not to store a ton of objects.
Right.
So I don't think a redirect is a viable problem shape, or is a viable solution shape.
Mm-hmm.
So the main question here, I'm just jumping in as a newcomer to this problem, but the question is whether to use existing infrastructure at the cost of maybe efficiency, or to invent something entirely new or efficiency. But then there's the problem of creating something entirely new. What's the dilemma?
Yeah. I think that
Well, the
third option as
infrastructure.
well is to do this outside of Ceph and not use an existing database to handle this kind of redirection metadata.
Got it.
Even reusing what we have, though, is sort of like inventing something new in a way, right?
Yeah.
That's
Right.
I mean, it's not. Yeah.
So in general, Sam, so if I had to ask you, what exists? I know there's a lot of code around this that exists in the source tree. So what paths do we have?
I mean, we have the ability to set a redirect up at the cache pool to an object in the base pool. Trying to remember, it doesn't actually have the ability to point to a sub-object. So the packing feature would still need to be implemented. That's a whole new thing that doesn't exist now.
Yep.
But again, I'm pretty sure this is flatly not viable. If the goal is to store a lot of these objects, then the metadata in the cache pool is already going to kill you. You have to store that efficiently, and by the time you chose to do that, you might as well store the objects themselves.
Sam, when I hear this, what it fundamentally breaks down to me for me is like, how do you efficiently store billions upon billions of files in RocksDB, or not files, but key value pairs? That's kind of not really a useful thing for us to be spending a lot of time on right now, I feel like.
No, RocksDB is perfectly well suited to that. That's not really a problem. The problem is, as you pointed out, that the ONode structure is a lot more. The structures the OSD keeps for its objects are a lot more powerful than what you need for very small objects. So yes, a small object pool where we don't keep most of the fields, where we assume immutability and other things is what we'd have to do.
Sam, I somewhat disagree with your premise that's RocksDB is well suited to this. They have a requirement that no first byte read of any object takes longer than 100 milliseconds. I don't think RocksDB can do that with like 10. Well, it's not in one instance, but just like maybe hundreds of millions to a billion key-value pairs or more in one instance.
I mean, we've only really done testing of RocksDB under the really specific conditions that Bluester uses it for. So maybe that's true, but I don't think we know that.
Lack of deletes helps, certainly. We talked about, Josh had mentioned that earlier, but I still think it's unlikely to work. Anyway,
is this some specific use case where they need to store a ton of small immutable objects? Is that the idea?
Yeah, this is based on the Software Heritage Foundation use case where they're kind of archiving billions and billions of tiny objects, namely the objects from Git repos,
I see.
And trying to pack them together and index them. Their indexing scheme is actually in a separate storage system, but they're planning to use Ceph purely for storing the contents of the repos and the potentially the mapping from.
I mean, at a high level,
contents.
There are things about Ceph that are well suited to this, namely using Crush to distribute the objects across OSDs was a good fit.
Yeah, so their design, their alternative is basically using RBD images that are that they have their own indexing scheme into, where they write a bunch of small objects into the RBD, have their own index within that RBD of which objects are where, and also store that information about how to look up the different repos in a separate database.
Yeah. Or a Rados object, but whatever.
Yeah.
Yeah, it does sound like Josh, you asked this question earlier, but if they want a solution as early as now or soon, maybe going the RBD route is a better way for them, given the state of the peering code.
Yeah, certainly. Right now, I think their time frame is more like 6 months to a year, but even if we started working on this stuff now, I think it wouldn't be ready for Quincy. So.
No, and I don't know that there are a lot of other users like this. That's the real problem.
Yep.
Like, this would be a large development effort. Like I said, the large-scale properties of Ceph seem to fit this well. As a way of distributing these keys across the whole cluster and dealing with recovery, whatever. But there are a bunch of details that really don't fit. Like, we like to do recovery on a per-object basis. That's flatly inappropriate for this. Even within the OSD, we'd want to pack them and only consider them on bulk during recovery or whatever.
Yep.
So I'm not sure this is even just a matter of making efficient onodes. This might be a matter of creating a pool where within each OSD we have a much more complicated indexing structure.
Yeah.
So if that's going to happen anyway, then I'd kind of rather they do it.
I don't totally hate, as I think about this, that they're dealing with objects from Ceph's perspective as being big coarse-grained things, and they deal with the problem of indexing these tiny objects themselves through some other, presumably fast mechanism. Rather than us trying to do it.
Do they have candidates for a database?
In the diagrams, they have Postgres clusters, and I think they're also using Cassandra.
I mean, it should be easy to come up with a partitioning scheme to get the scale to where it'll work. One wonders at that point why you don't just store it in the database, though.
Yeah, this data is not big. And they're saying like 50% of it is under 4K.
And they're concerned about the massive scale that they're going to have. So it's my understanding why they were looking specifically at Ceph for that contents.
It's the metadata data ratio. So if what they're going to be storing is a say an 128-bit identifier for each one of these, and what it's get hashes. Is that what we're talking about?
Essentially.
So it's an 128-bit to 128-bit mapping. Anyone want to do math for me? How many bytes is that? Just woke up. 128 divided by 8. 16. 32 bytes per key value pair. If it's 4K of payload, then Python. Anyway, I'm worried that the metadata cluster ends up being an appreciable percentage of the total storage footprint.
Absolutely.
But I guess it's still a solid factor of 10 less, so maybe it's still worth it.
I mean, one of the requirements here is there is no space amplification for objects, but that's kind of BS, right? I mean, I guess it depends on what they mean by that, but they're certainly going to have metadata overhead.
Oh, sure. There's like going to be metadata overhead in any kind of system. I think it's really about like minimizing that rather than by the packing strategy.
I'm not complaining about the existence of the overhead. I'm saying that if the second metadata storage system is big enough, it might be better to simply expand it by a factor of 100 and use that as the only system, thus avoiding Ceph entirely. But I'm not sure that's true. In fact, I'm sure it's not. This actually does make sense. Assuming they don't try to store anything else in the metadata system. That would make it bad.
I'd say since Sage missed this discussion, I'm adding you to the next meeting with them later today, so we can talk more at that point.
What time?
9:30.
I'm giving a talk at 10:30, but I should be able to make that.
Okay, cool.
All right. Well, what do you think, guys? Anything else to discuss on this, or do you want to continue on in a different meeting?
I think we're good for now.
All right, cool. Thanks for joining, Sam.
Yep.
Appreciate your input.
Thanks, Sam, for jumping in.
Yep.
Cool. All right. Well, have a great week, everyone. We'll see you next week.
Thanks. See you, everybody.
You too.
Bye.
Thanks.